Hello and welcome to my video, lesson 1.1 on perfect squares, perfect cubes, and prime factors. So this is for Math 10C. This is where we start in my course, yeah, let's go ahead and get started. So to begin with, we hopefully all know about perfect squares. Hopefully that's a topic that is not new for you. And here are the first ones. We recommend that you memorize the first ones. So the ones in green that I have labeled here from 1 all the way to 100, so 1, 4, 9, 16, 25, etc., all the way to 100, should be memorized, and I even recommend memorizing 2 more, which is the 11 times 11 and the 12 times 12. All of those, if you have them memorized, it'll just speed things up when you're doing these questions significantly. Okay? So these are perfect squares. What makes them a perfect square? Well, basically, that if you do 1 times 1 equals 1, or another way to say that is 1 squared equals 1, and then 2 squared equals 4, and then 3 squared, etc. So I made that one really fat just by pressing too hard. But anyways, you get the idea here. 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. So squared means a perfect square. Another way to say that is it's a perfect square because a square, a literal shape square, is length times width, or because length and width are equal to each other, we can say side times side. Or a better way of saying that is side squared. So therefore, the area of a square is a squared number, and that's the whole point. So a perfect square is the value of the area of that square. All right, continuing on from perfect squares, we can also talk about perfect cubes. Perfect cubes are the same thing, except a cube is now a 3-dimensional object, and so therefore we talk about volume, and we talk about length times width times height, and so a perfect cube is the volume of a cube with whole number sides. So the volume of a cube with whole number sides. So basically 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64, and 5 cubed is 125. I recommend memorizing all of these, but the green ones are very much necessary. The 4 and the 5 maybe a little less so, but up to 3 would be very, very helpful for you. Okay, and continuing on, we can just do that pattern forever, but here is a perfect fourth, so it's 1 to the 4, and then 2 to the 4, and then 3 to the 4. Those are just a couple examples. Those ones, again, I recommend you have memorized. So it's 1, 16, and 81. And perfect fifth would be 1 and 32. Perfect sixth is 1 and 64, and so on and so forth. So you could continue this on, but for now, that's where we're going to stop. So let's continue on and say and try a question here. Find the side length of the following objects or shapes given the area or volume and the units shown. Label each as a square or a cube. So here there are different numbers in here, and you need to label it as a square or a cube, and it's not telling you if it's the area or the volume. It could be one, it could be the other. And you need to give the final side length of the shape. So I recommend pausing the video now, trying this out for yourself, and then pressing play. All right, hopefully you were able to do that. I'm going to do the first example, and then I'll do the next couple a little bit faster. I'll do the first one slowly so that if you weren't able to do it yourself, you can try that out with me, and then you can pause it again and try the rest of the questions. So 121 is the side length, and helpfully it tells us that it's squared. So actually, we can go through and just say, well, if this is squared, then it's going to be a square. Okay. Now, some of these are labeled, or all of these are labeled, but you could be given a question where it's not labeled, and that would be a little bit more difficult. So let me just think about an example like that. Oh, I was going to do that number, but that's no good. Let's do that number, okay? So I'm going to leave that there as well as the challenge problems at the end. Okay, so for 121, if we want to figure out the side length, what you should do is do a prime factor tree of that number. And unfortunately, there's really not much you can do other than divide by 11. There's no more other prime numbers, so the side length is going to be 11. Okay, what you could do for the next one though, 125, you can do another prime factor tree, so 5 and 25, and then 5 and 5, and because there are 3 of them, that makes it a cube, and so the answer is 5, because there's one group of 3, and it's a 5. Okay, 27, we do the same thing. So 3 and 9, 3 and 3. Put those together, it's 3, and it's a cube. Okay, 1, you can't really break it up. Like, you can break it up to as many ones as you want, right? So this could be a square or a cube. So this is kind of both, but because of the units, it's a square. I think that's just a mistake. Oh no, actually, you know what? I think we can do that. Okay, so 17, and it says that it's squared, so that means it has to be a square number, right? So if that's the area is 17, if we square root that, actually let's show it all by hand. So area equals 17, and also equals side squared. So if we want to find the side length, we do opposite operators and opposite bedmass. Then we can cancel square rooting and squared. So square root of 17 equals s. And this is my favorite number. The square root of 17 is my favorite number. And so what we do is we write 4.123. Isn't that a beautiful number? Although there are decimals that continue after that. Okay, 32. If we do a prime factor tree for that, it's 32 is 4 and 8, 2, 2, 2, 4, 2, and 2, and yeah, there's not much we can do except since it is cube rooting, we can take out one group of 2, and we could say that there's a 2 times 2 inside the cube root. We'll get to this example a little bit more later on, but anywho, this is what it would look like if you're trying to find the exact answer. That would be the best answer. So I'm going to write this over here as the best answer would be this, or you can type it in your calculator, which is for me not actually open right now. It'll start booting up now, and then I'll show you for that one. Okay, and last example, 64. Oh, and that's a cube because of the centimeters cubed. If this is a perfect square or cube, then we can do the prime factor tree. So actually, let's do 8 times 8 is 64, then 4 times 4, times 2, sorry, times 2 times 4, and then times 2 times 2 times 2 times 2. What you'll notice is that we have a group of 3 and a group of 3 over here, so it is both a perfect square and a perfect cube, and it is 2 times 2, so it is 4. So why am I doing 2 times 2? Well, there's one group here, one group here, so this one is one of the 2's, this is one of the 2's, and we take those 2 together, and that's where we get the 4 from. Okay, and like I said, I was going to boot up my calculator here, so here it is. So 2, math, down to number 5, and then we go, oh, whoops, that won't be perfect, but that's okay. We'll go back actually to put a 2 here and make that a 3. And now it looks exactly the same, and now we press enter, 3.175. Let's leave it there, yeah, 175. So 3.175 ... All right, hopefully this video explains a little bit about prime factors and perfect squares and perfect cubes. Prime factors are just using this prime factor tree to get down to these last numbers. So we're just dividing by whatever number that we can in order to get to our last number. So yeah, that is it. Yeah, have a good day and see you in the next one. Bye everyone, good luck.